So the design presenting a solution to a critical problem faced by ultrasound physicians, musculoskeletal disease caused by long working hours and poor posture. So the sonographers have one of the highest rates of musculoskeletal disorders in the medical field, with 90% of them suffering from work-related pain and 20% having to end their careers permanently because of it. So this problem stems from the increasing demand for ultrasound services, which is driven by population growth and the aging problem. Given the high safety and low radiation of the ultrasound scanning, it is a popular diagnostic tool in the hospital. However, this leads to a heavy workload for every sonographer. Usually, they're working with 50 plus patients per day, performing diagnostic procedures for 8 minutes per patient. The lack of time for self-care and the long hours of repetitive movements result in severe health issues. This brings us to my proposal solution, a modular design with a bending sensor and simple electric structure that provides real-time feedback on spine posture, helping the sonographers to monitor and adjust their body posture during their work, particularly in the neck, shoulder, and the wrist areas caused by poor posture and their repetitive motions. Studies shows that 90% of the ultrasound sonographers suffer from these issues. So I first became aware of this issue through a friend, a sonographer trainee who was already dealing with musculoskeletal pain. After talking with several senior sonographers and review some of the research, I discovered that the main cause of these health issues is a high workload and their poor posture. For example, the elbow during the whole process is constantly suspended in the air, and the wrist bears the majority of the load, and the body tends to lean towards the patient during the scanning in order to get a better scanning quality. Over time, these small stress accumulates and result in significant health problems. In brainstorming potential solutions, I consider several approaches like variable sensors, ergonomic supports on the chairs, and rethinking the working environment by providing additional structures. The final decision was to use real-time feedback signals that could alert the sonographers when their posture is compromising their health. After testing various types of signals through a experiment, visual, auditory, and tactile, I decided to focus on the visual signals. From the feedback I received from the sonographers, the visual signals are the least invasive for them, and it can be integrated into the workflow without disrupting their patient care. Then I move on to the product iteration and then technical implementation. First of all, I designed a modular spine simulation system that gives a visual representation of the sonographer's posture. These allow for easy and direct feedback regarding their alignment. The system used some 4 of the bending sensors embedded into clothing, which continuously monitor the sonographer's spine angle and transmit data to the device. The initial iteration experiment with commercial servo motors found that the structure that I was designing was too fragile and they lack stability. Therefore, I continue to iterate to transition a 360-degree rotational connection structure that ensures the system remains flexible yet stable. So the design's workflow would be, once the device is turned on, it automatically sync with the variable sensors, and then they would continuously monitor the sonographer's posture. Once the abnormal posture for example, slouching or excessive bending from their spine is detected, the system will provide a visual signal, a representation of the spine status to alert the sonographers. And once the sonographers notice, they would correct their posture, and then the system would detect normal data, and then they would reset to a normal alignment. So one of the key aspects of this design is its focus on the sustainability. First of all, the outer casing is made from recycled PLA and PC plastics, which are commonly found in medical waste. These materials can be disinfected with UV light and reproceed into 3D printing filament, reducing waste and lowering the carbon footprint during the production. Secondly, the modular design its nature means that the part can be replaced without discarding the entire system, extending its lifespan and further reducing electronic waste. Additionally, the low carbon manufacturing by using 3D printing and their recycled materials would significantly reduce the environmental impact of the manufacturing process, helping to improve resource efficiency and reduce pollution. And last but not least, the potential for this product to expand is immense. First of all, compared to current solutions on the market, which often rely on unreliable posture sensors or have short lifespans, this product offers a real-time prevention using sustainable materials. It's a more reliable, durable, and eco-friendly option for the sonographers. And secondly, these technology have a broadening applications. They can also be adapted to other medical fields, and the modular design allows it to be customized for various type of professionals who face similar musculoskeletal disorders, similar posture issues. And then beyond healthcare, it can be also applied in industries such as manufacturing, where workers are required to maintain certain postures for long periods. And then with further development, I believe it could integrate other, for example, machine learning to monitor health trend over time, offering deeper insights into a professional health and providing predictive alerts for potential issues before they become critical. So to conclude, this product provides a sustainable and effective solution to a processing issue faced by sonographers. It not only helps prevent these conditions by offering a real-time feedback on posture, but also promotes a more eco-friendly approach to medical device design. This project represents an existing opportunity to combine healthcare, technology, and sustainability, with the potential for future iteration to address even more challenges in various industries.